Hello, welcome to my channel. So for today's video, I will show you how to perform the non-parametric alternative of analysis of variance or ANOVA. Particularly, we will focus on the Kruskal-Wallis kasi there are other statistical analysis for the non-parametric alternative of ANOVA. So aside from Kruskal-Wallis, we also have Jonquier-Terpstra and median test. So for today's video, we will focus on Kruskal-Wallis. And if the findings show significant difference, then we will apply Bonferroni Correction to avoid encountering type 1 error or false positive. The Kruskal-Wallis H test, sometimes also called the one-way ANOVA on ranks, since it is a non-parametric alternative, instead of using the mean and standard deviation, it will use medians of rank data. So it is a rank-based non-parametric test that can be used to determine if there are statistically significant differences between two or more groups of an independent variable on a continuous or ordinal dependent variable. It is also considered the non-parametric alternative to the one-way ANOVA and an extension of the Mann-Whitney U test. And that is to allow the comparison of more than two independent groups. Remember that Mann-Whitney U test is the non-parametric alternative of t-test if the data is not normal. So same with t-test, we can use ANOVA if we only have two-factor groups. So kaya din siyang gawin ng ANOVA. It's just that it is more advisable that if you only have two-factor groups, much better to use the t-test for independent samples since yung t-test talaga is designed in comparing two-factor groups. And then for the ANOVA naman, much better kung more than two groups yung ko-compare natin. So same scenario that we had in ANOVA. So as a researcher, you want to determine if there is a significant difference in the level of social entrepreneurial intention or SEI among different year level of university students. So we have four pairs. So we have first year versus second year versus third year versus fourth year. And we will answer the research question, is there significant difference in the level of social entrepreneurial intention among different year level of university students? And from the research question, we formulated our hypothesis that there is no significant difference in the level of social entrepreneurial intention among different year level of university students. As I've said, for every research question pertaining to inferential statistics, we have to perform normality tests. So I have a separate video on how to perform normality tests using the Kolmogorov and Shapiro-Wilk test. So pwede nyo siyang hanapin dun sa channel ko. Ang title is Normality Test. So suppose that we already perform the normality test using our variable, yung SEI, and our factor groups, which is the year level. We will use Shapiro-Wilk since our participants or respondents are less than 2,000 because Kolmogorov-Smirnov is applicable if you have more than 2,000 participants. And as I've said, we will just look for the SIG. SIG is considered as the p-value. So kailangan hanapin natin dito yung sa SIG para malaman if we will use parametric test or non-parametric test. So for the first year, the obtained p-value is 0.043, which is less than the p-value or less than the level of 0.05, p-value of 0.05. So the interpretation is that we will use non-parametric if the obtained value is less than the p-value of 0.05. Then for the p-value or for the obtained value for the second year, we have 0.545, which is greater than the p-value of 0.05. And for the decision, we will use parametric. And then for the third year level, we have 0.080, which is also more than or greater than 0.05. So we will use parametric. And last is fourth year. We have the obtained value of 0.138, which is also greater than 0.05. Then we will use parametric. For the final decision, even there's only one factor group that will show that the data is not normal, then the final decision is we will use non-parametric. Kasi titingnan nyo, first year non-para, second year to fourth year parametric. And as I've said in my previous video that parametric is sensitive to outliers. So kailangan lahat ng factor group mo ay normal, yung lumabas doon sa normality test. So for the final decision, we will use non-parametric equivalent of ANOVA, which is Kruskal-Wallis Test. So this is the command that we have to use in our SPSS. First is go to analyze, then non-parametric test, then legacy dialogues, and look for k-independent samples. So let's perform that in our SPSS. Okay. So this is our, wait. Okay, so this is our SPSS. So again, this data is already kumbaga, completed or ready for processing na. So, kailangan ay you have to assign values in your nominal scale. Then, you can look for the video naman na nasa channel ko about descriptive statistics kung paano gagawin itong mga to. So, itong data natin ay ready na for processing. So, again, we will perform Kruskal-Wallis. So, click Analyze. Then, since it is a non-parametric, we will click non-parametric tests and then legacy dialogues and then look for k-independent samples. Yan, click natin. Again, analyze, non-parametric tests, legacy dialogues, and then the k-independent samples. Yan. And then, for the test variable list, look for the overall mean of your construct or variable. So usually yung mga ganyan na na-process na nasa overall mean, nasa bandang dulo yan nung sa list mo. So SEI, click SEI and click this arrow para mapunta sa test variable list. And then for the grouping variable, since we will compare the year level, look for the year level and click this arrow para mapunta sa grouping variable natin. And as you can see, merong question mark. So we have to define our range. Since we have 4 groups, di ba? Yung first year, second year, third year, fourth year, minimum is of course yung mga first year, 1. And then maximum is fourth year. So 4. Then continue. As you can see, Kruskal-Wallis is a default test. So, yan na yan. Huwag nyo na siyang i-unclick. Rekta nyo na yan. And then, okay. So, okay na tong mga sa command natin. Just click okay. And then, let's just wait for the results. So, mapapansin nyo, comparing the results from ANOVA, mas simple yung pinapakita na results ng Kruskal-Wallis. Ang importante lang din dyan, ito, sama na natin yung ranks, mean rank, para, di ba nga, para mapakita na it really uses the mean rank instead of the mean and the standard deviation. And this will also be reflected in our results and interpretation. And then, yung pinaka-importante dyan is, of course, the test statistics and check for the asymptotic sig to determine if the result is statistically significant. So, discuss natin to sa PowerPoint natin. Ang kagandahan nga kay SPSS, copy-paste nyo lang, paste nyo sa PowerPoint, sa Word niyo, kayang-kaya niya. Sige, discuss natin yan sa PowerPoint. Okay, so to determine if the findings are statistically significant, let's analyze the obtained value dun sa p-value natin, dun sa asymptotic sig. So to determine if the findings are statistically significant, the obtained value must be lower than 0.05. So yung nakuha natin is 0.001, which is less than the p-value of 0.05. Therefore, there is a significant difference. May pagkakaiba. Same with ANOVA na the limitation of Kruskal-Wallis, it will just answer the question that there is a significant difference. But it cannot answer the question saan nagkaiba. Where does the difference or significant difference lie? That's why we have to perform post hoc test, katulad doon sa ANOVA. So isasagot ni Kruskal-Wallis, may significant difference based on the findings, pero hindi niya masasagot kung saan nagkaroon ng significant difference. That's why, same with ANOVA, we have to perform post hoc test para malaman kung saan nagkaiba. So we can use this interpretation for the results of Kruskal-Wallis. The Kruskal-Wallis test revealed that there is a significant difference in social entrepreneurial intentions among university students when grouped according to their year level. Then we can state here the chi-square to, which is 16.136, and of course the p-value para malaman na it is statistically significant. Then to finalize our data that will be reflected in our research paper, we can just use of course, we have the year level, the sample size or the population size, and then the mean rank. So yung mga ito ay, ayan, ito yung sa year level, then yung N, yung mean rank, and then the results for the chi-square, ito siya, then the degrees of freedom, ito, yung 3, and then the asymptotic sig or yung p-value natin to determine that our findings are statistically significant, yung 0.01. Yan. So yan siya, how to finalize when we are finalizing our table for the results of Kruskal-Wallis. Okay. After we finalize our table, then we can come up with our interpretation nga. So ito yung kanina. So ito yung gagamitin na natin. So the Kruskal-Wallis test revealed that there is significant difference in social entrepreneurial intentions among university students when grouped according to their year level. So indicate the chi-square and the p-value. Then as I've said, same with the ANOVA, we cannot determine kung saan nagkaroon ng difference or pagkakaiba. That's why we have to perform post hoc tests. Particularly, we have to conduct pairwise comparisons using Mann-Whitney U, and we have to apply Bonferroni Correction to make sure that we will avoid having type 1 error in our results. So to do the Bonferroni correction, yung from the alpha level of 0.05, i-divide lang natin siya doon sa number of tests na ginamit natin. For example, we have 3 pair comparison. Sabihin natin first year versus second year versus third year, then third year versus first year versus second year versus third year versus fourth year. So 3 pairs lang siya. So in case that we use 0.05 level of significance, so i-divide lang natin siya doon sa number of pairs na meron tayo doon sa study natin. So 0.05 over 3, then we will now use the new alpha level, which is 0.017. So from 0.05, bumaba siya ng 0.017. So para masabi na our findings are statistically significant, the p-value that we will obtain from our findings must be lower than 0.017. Okay. Then, sabi nga natin, we have to perform post hoc test using Mann-Whitney U. So this is the command that we have to perform in our SPSS. First is click analyze, then non-parametric tests, legacy dialogues, and look for 2 independent samples test. So ito yung sa Mann-Whitney U natin. So gawin natin siya ulit in our SPSS. Okay, so let's perform the post hoc test, analyze the non-parametric tests, legacy dialogues, and look for 2 independent samples. So again, analyze non-parametric tests, legacy dialogues, and look for 2 independent samples. Click natin yan. So as you can see, the Mann-Whitney U is a default statistical analysis here. So wala na kayong babaguhin dyan. So for the test variable, again, we will use the overall mean of our variable, which is social entrepreneurial intention. So click natin yan, then click this arrow para mapunta kay test variable list. And then for the grouping variable, we have the year level. So click this arrow. Then may question mark ulit. So we have defined our groups. By the way, para maging clear, ito yung sa group natin. Ayan, sa test 1 natin, we will compare first year and second year. And then second group, first year and third year. Then first year to fourth year, second year and third year, second year and fourth year, third year and fourth year. And to determine if it is statistically significant, the obtained value must be lower than 0.008. Ayan siya. Para nakuha yung 0.008, yung level of significance na 0.05, i-divide nyo lang doon sa comparisons or doon sa mga pairing ninyo. So we have 6 pairs. 1, 2, 3, 4, 5, 6. Kaya 0.05 yung level of significance, i-divide sa 6 comparisons. Then we have the new value for the alpha level or the p-value, which is 0.008. So determine if the test is statistically significant, the obtained value must be lower than 0.008. So this is the Bonferroni Correction. So naayos na to. So isa-isayin natin. First year and second year. Ayan. So define natin yung groups natin. So una muna, di ba, sabi first year and second year. So group 1 natin, first year, and then group 2, second year. Then continue. After nun, just click OK. And let's just wait for the results. So ang titingnan lang natin dito ay yung sa asymptotic sig. 0.458. So discuss natin yan in our PowerPoint. Since the obtained value is 0.458, which is greater than the alpha level of 0.008 using the Bonferroni correction, it means that there's no significant difference between first year and second year. So wala siyang significant difference. Try naman natin yung second pair natin, yung first year and third year. Since same naman din yung process na gagawin natin, naturo ko rin to, just click the recall button. And then, at andito yung mga previous na process na pa-perform natin. Is parehas naman din yung gagawin natin. Para hindi na tayo mag-analyze, tapos non-parametric. Kasi isa-isayin natin to medyo mahaba, di ba? So mag-shortcut tayo. Click this icon, yung sa recall button, then 2 independent samples test. Then, same naman din, di-define lang natin yung sa group natin. So we're done comparing first year and second year. Punta tayo sa first year and third year. Yun naman ang co-compare natin. So define groups, palitan natin yung 2. Gawin natin 3. Then click continue, then okay. So check natin ulit sa PowerPoint kung significant ba. Again, ang titingnan lang natin ay yung asymptotic sig. So for the comparison between first year and third year, the obtained value is 0.283, which is greater than the p-value of 0.008. So the interpretation is there is no significant difference between first year and third year. So medyo mas madugo kapag kay Kruskal-Wallis for the post-hoc test kasi kailangan natin i-apply yung Bonferroni para maiwasan natin yung false positive. Akala natin significant pero hindi naman pala. So try naman natin ngayon yung group natin na first year and fourth year. So again, same process. Ang gawin na lang natin ay ito, yung recall button. Then two independent samples. Click natin to, then define groups lang. First year and fourth year naman. Tama ba? Ayan, first year and fourth year. Then continue. Then okay. So hintayin natin ulit. 0.009, discuss natin sa PowerPoint. So the obtained value for the comparison between first year and fourth year is 0.009. Sayang, di pa mataas pa ng isang level pa. So it means it is not significant or there is no significant difference between first year and fourth year. Meron pa tayong remaining 3 groups. Tingnan natin kung saan may pagkakaiba. So same process, click this icon, yung recall button, and then two independent samples. This time naman, we will compare second year and third year. So click grouping variable, define group, tapos palitan natin to ng second year and ano yun, third year. Okay, third year. Then continue, then okay. Sige, check natin to sa PowerPoint. So for the comparison between second year and third year, still it is not statistically significant since the obtained value is 0.04.8, which is greater than 0.008. So meaning there is no significant difference between second year and third year. Wag magano, wag sumuko, meron pang dalawa. Okay, sige. So recall button to independent samples. This time naman, click this grouping variable, define groups. We will now compare second year and fourth year. Yun naman ang compare na second year and fourth year. Continue, then okay. Ayun. So ayan na siya, lumabas na. So comparison between second year and fourth year, the obtained value is 0.000. So 0 siya. So talagang ano siya, it is less than 0.008. So it means that there is significant difference between second year and fourth year. Di ba remember in our Kruskal-Wallis, may lumabas na it is statistically significant. So hanapin natin ngayon using the post-hoc test for the, using Man-Whitney U, kung saan nagkaroon ng pagkakaiba. So may lumabas na isa, second year and fourth year. Meron pa tayong isang group. Malay nyo, meron din dito, di ba? So check natin. So two independent samples. So click this variable, grouping variable, define groups. Anong di-define natin? Third year and fourth year naman. So third year and fourth year. Click continue. Okay. And then, ayan, 0.137. So check natin. So the obtained value for the comparison between third year and fourth year is 0.137, which is greater than with our p-value of 0.008. So the interpretation is there's no significant difference between third year and fourth year. So to finalize our results, we can come up with this table wherein you have to show the multiple comparison, kung ano yung mga groupings na ginamit mo, and then the results of the U, Man-Whitney U. Ito siya, ayan, nakalagay naman Man-Whitney U. And then the Wilcoxon, yung W, ito rin siya, yung Wilcoxon. Or pwede naman din na you can just remove yung the result of Wilcoxon kasi may Man-Whitney yun eh. And then the Z-score and the p-value. So ito yung mga na-compute natin para malaman kung statistically significant ba or meron bang significant difference among our pairs. So dito, pwede nyo lang ilagay ay, pwede nyo i-highlight or you can just put asterisk. And then for the interpretation, Kruskal-Wallis post hoc test using pairwise comparison was used. So you have to state that para malaman what kind of post hoc test you perform, para malaman kung saan nagkaroon ng significant difference. Was used to identify where the significant differences in social entrepreneurial intentions among university students when grouped according to year level. In order to ensure that the type 1 errors do not build up to more than 0.05 to avoid encountering type 1 error or false positive na akala mo it is statistically significant pero hindi naman pala, a correction using Bonferroni Correction was established. So this is the formula that we used for the Bonferroni correction. In case that we will use 0.05 level of significance, just divide that to the number of pairs or comparisons. So in our case, we have 6 pairs. Ito, in first year, second year, first year, third year, first year, fourth year, second year, third year, second year, fourth year, third year, and fourth year. So 2, 4, 6 comparisons. Then the findings reveal that there is a significant difference in social entrepreneurial intention between second year and fourth year level students. So with the Mann-Whitney U result of 3,549, so as I've said, you can just omit or don't include the Wilcoxon test na since we already have Mann-Whitney U, and then the z-score and the p-value, which is yan, 0.001 or less than 0.001. Kasi nakuha natin dito, di ba, 0.00 siya. Okay, so that po the end of my demonstration. So medyo maraming process in case that the data is not normal, then we will use the non-parametric alternative for ANOVA. Pero at least talagang nabusisi natin para malaman kung saan talaga nagkaroon ng significant difference. So again, by just wait for the other videos that will be posted in my channel. So after this, we will perform the Jonquier-Torpstra, which is another non-parametric alternative for ANOVA. Okay, so don't forget to subscribe to my channel. Thank you. Bye.